Okay. Hi, my name is Ray Cromwell, and this is Daniel Kurka, and we are engineers at Google who work on GWT, and this is a GWT roadmap for the future. Now, if you're here last year at Google I/O, there was a session called The History and Future of GWT, where we talked about creating this new GWT Steering Committee that was going to be in combination with Google, as well as some of the top heavy hitters in the GWT community, people like Senja, people like Vaadin, like Red Hat, to help define the roadmap for GWT in the future in a way that takes the community's needs into account and not just Google's internal needs, which has been driving GWT over the last couple of years. And so what I'd like to do is talk about what's happened since last year when we announced that. So the steering committee has met several times, and we've had a lot of discussions, and we've implemented some changes to the project based on those discussions. So the first thing is we have moved the GWT source code to a Git repository, now hosted on gwt.googlesource.com. Secondly, we've migrated to a totally new revision code review system called Garrett, which is much nicer than the old system we used, and it's much more of a pleasure to use, in my opinion. Third, if you like the GitHub interface, or you really like working on code on GitHub, we actually mirror GWT to GitHub now, so you can go to github.com/GWT project and track the project there. Fourth, Red Hat has graciously allowed to donate some resources from their OpenShift cloud to basically build, to do continuous integration builds of GWT. So like every time there's a commit, we'll do a build, run tests, and we'll push out nightly snapshots very, very soon. Finally, there's a totally new home for the GWT project, which Daniel's going to talk about a little bit later. So there's been some steering committee updates as well. So I announced last year the members of the steering committee. I'm not going to go over the complete list, but we've added JetBrains, makers of IntelliJ IDEA, which in my opinion is like the most awesome IDE there is. They also make the new Android IDE for Google. So they are now a member of the steering committee, so hopefully that means really good things in terms of GWT support within IntelliJ IDEA, which already actually is pretty good. The steering committee also met and approved a roadmap, which I'm going to talk about today, for GWT 2.6 and beyond. And third, there's been a start of what we call decentralization. What this means basically is some of the pieces of this roadmap, which external people have proposed, now have external leaders. These are people who are going to take responsibility for those pieces, and they're going to drive them. For example, Vaadin is going to drive IE10, Windows Phone, Microsoft Surface support. Thomas Breuer is fully Mavenizing GWT into modules, and he's taking over Request Factory support. We also released a new version of GWT since last year, GWT 2.5.1, mostly bug fixes. There were a couple of improvements. One, for example, is the direct install linker now supports content security policy, so you can build GWT apps that install as Chrome apps and extensions. There's a couple of other things we've improved, but you can see the full set of changes online. Let's talk about the future. I think that's what most people in the room are curious. They're worried about GWT. They're wondering, is it getting stale? How's it going to evolve in the future? So the steering committee met several times just recently. We had our own summit 2 days before I/O where we got together over 2 days, kind of huddled down in a bunker. We discussed what we're going to do going forward. First, we defined a set of core principles and areas of focus that we think and we believe that GWT should address going forward into the future, and we've agreed to them by consensus. Those are openness and simplicity, speed, interoperability, mobility, reliability, and embeddability. First, let's talk about openness and simplicity. What does that mean? I talked about this at I/O last year, but basically we want to complete the move to open source to make it easier for everyone to join in and contribute going forward. GWT steering committee members are now allowed as direct committers. This is the first time in several years. That means someone can actually make a patch and just commit directly to the source trunk of GWT. We have a public continuous integration server, so like very soon as we pushed out nightly snapshots, so if you don't want to wait for GWT 2.6, you can just depend on that in your Maven dependency file and just pick it up nightly. Speaking of that, we're going to fully Mavenize GWT. So you don't just have to pick up the whole GWT.user SDK. Maybe you only want to use GWT core, GWT IE10N, and some GWT widgets, but you don't want Request Factory, or you don't want GWT RPC. So by breaking GWT up into smaller pieces, you can actually speed up your compiles and also prune your dependency tree. So I think that's going to be more exciting going forward, because should enable iterating faster. And we're going to have regular public steering committee members meetings, and some of those actually will probably be done with Hangouts on Air, so you'll actually be able to join and watch the debate as it happens. Simplicity. The GWT SDK is basically monolithic, and that means that there's a lot of interdependencies that makes it hard to modularize it. And so working on disentangling those dependencies and breaking up into smaller pieces, making everything simpler. We're going to try to reduce the need for GWT.xml files. So if you don't really, not really using deferred bindings and you're just using it for declaring inheritance clauses, maybe we can have something that's simpler. And we're going to delete a lot of deprecated code that's sitting in there. It's been in there since like GWT 1.1, GWT 1.2. Stuff like Safari 2 and 3 browser support. Anybody still care about Safari 2? There's a lot of stuff in there that's cruft, and we need to basically, to move forward, we need to go back and remove some stuff that's holding us down as technical debt. Speed. So GWT has always been about speed. We've always cared a lot about download speed, latency, code size, execution speed, but we haven't really talked a lot about compile speed. And I know a lot of people have complained in the past about the compiler in terms of its speed. So minimally, we're looking at doubling the speed of the compiler, and also improving the speed of super dev mode refresh, so it becomes a lot more viable as a real replacement for dev mode if you should so choose. And we're going to continue to improve on code size, especially as we talk about mobile, including improving the code splitter to make it a lot simpler to use, not so much of a black art to find the right places to insert your split points. You know, GWT was created actually even before V8, and so you know, those were the dark ages of browsers. And so we've heard some talk about the fact that JITs and browsers with JavaScript have evolved so much that the compiler might be outputting code that's suboptimal for some of the very newest browsers. So we need to actually look at that, figure out what we need to change to actually fully leverage like the newest browsers, especially on mobile. And just to complete the performance and speed story, we need some better tools for profiling and spotting performance problems in GWT apps. Okay, interoperability. GWT's always had an interoperability story, which is the JavaScript native interface. I'm sure everybody who's been using GWT for a while has probably written one or two over the years. But if you want to wrap a JavaScript library that says a few hundred methods, you end up writing a lot of Disney methods. It's just a lot of boilerplate just to consume an API. And we want to make that a lot more automatic. We think you should just be able to drop a library in, and there should be some tool to just automatically generate overlay types by just looking at the JavaScript itself. That's going to entail improving integration and support with the Clojure compiler, which does a good job at type inferencing, as well as accomplishing the first two items will allow us to support hybrid apps efficiently. That means like maybe you've got 80% GWT code and you've got some web designers who want to sprinkle in a little bit of JavaScript. It should be easy to do cross calls between the two without a lot of effort. Likewise, maybe someone's got a JavaScript app that's like 80% JavaScript, but there's some Java library out there they want to consume. And so the JavaScript programmer should be able to just make a call directly to Java code. And it should be really easy and painless to do that. But I think the thing that people are going to be most excited about is a commitment to full Java 7 and 8 support. So we haven't really announced it yet, but there's actually a patch about to land in GWT very, very soon that fully enables Java 7. That means all the newest Java 7 language features will basically be available in GWT, including try with resources, multi-catch, diamond operator, you name it. And so it's been a long time since we upgraded the language support, and now we're finally starting to do that. But the real thing that I think people are waiting for is lambdas in Java 8. And so the minute that Oracle launches Java 8, and there's a JDT library that's released that supports parsing Java 8 source code, we're going to jump right on that, integrating that into GWT, so you can just start using closures or lambdas for all of those event or asynchronous-based APIs. Okay, reliability. If you've been looking at the issue tracker over the years, you might have noticed it's kind of stale, doesn't seem to get much traction. You filed bugs, no one pays attention to them. And I kind of talked about this last year at I/O, but we really apologize for that. Some of it's basically that we have our own internal issue tracker, and as more and more GWT apps were created inside Google from really important teams like AdWords or like at the other GWT presentation earlier, Wallet. They file bugs on us too, and we tend to fix the ones that are first from the internal Google apps, and then we look at the external repo, and it turns out the external repo got really stale. So the steering committee members are basically going through one line, bug by bug in the external repository and closing issues that are really stale, for example, like Safari 2, 3, or IE6 bugs. And bugs that have a lot of votes, we're actually going to start looking at fixing them and closing them. We're also going to try to improve GWT unit testing to make it a lot less painful. A lot of people don't bother writing GWT test cases just because invoking them is really slow, and they tend to be flaky sometimes, especially in browsers like IE6 and 7. And so we're looking at improving that experience and making round-tripping unit tests with GWT and SuperDev mode to be a much more pleasurable experience in the future. But really, just to confess over the years, in terms of what breaks the GWT build and what breaks GWT apps, 99% of the time, it's IE6 and 7. Someone commits a change to GWT, the unit test suite runs, the breakage is always in some IE6 or 7 class out there somewhere. So a big part of this is for GWT 3.0, not the next release, but the release after that. We're going to remove IE6 and 7 support finally and bury it. It's like a vampire. It seems like you can't kill it, but we're going to try. Yeah. And this will remove a huge technical debt. For example, when Daniel talks about mobile later, it's really hard to design an efficient mobile widget API if you have to support IE6 layout engine. Finally, well, not finally, but embeddability. So some people actually build tools like Red Hat, Vaadin, Sencha, and they tend to actually need to use pieces of GWT. Like maybe you don't want to use the whole GWT compiler, but you want to basically use the part that can like parse some Java and hand you back like an AST of the source, and maybe you want to like filter over the source and do some transformations. Maybe you want to do static analysis tools, look for bad code. And so we're going to start trying to like break it up a little bit and add more public APIs so that you can just pull out a piece of GWT and like reuse it or embed it in another tool chain. So now we come to mobile, which is, I think is the most important part of this presentation. Maybe it's the most exciting thing yet. So as you may have heard over the years, mobile has been becoming increasingly important. It really is the most important thing now. For some key metrics on some applications, mobile usage has surpassed desktop usage. But GWT was created in the era of desktop apps, back in 2006. And so there wasn't a lot of thought back then given to actually designing it to efficiently support mobile apps. It turns out, actually, it is pretty good for building mobile apps, which it has some core fundamentals that enable that, and Daniel's going to talk about that later. But some of the key things we decided for the roadmap on the steering committee is to support modern mobile web browsers directly, to create a set and support a set of mobile optimized widgets, so you don't have to worry about jankiness, to integrate with application lifecycle and on and offline detection on mobile devices, and to support package app deployment. So if you want to put a GWT app in an app store, it should be really easy to do so. And with that, I'd like to turn it over to Daniel Kurka, author of the excellent and fabulous mGWT library, if you've never seen it, and newly minted Google employee and member of the GWT team.
Hello everyone, I want to talk about GWT and mobile, and as it turns out, performance on mobile is really important, because on performance we do have slow CPUs, we do have slow network connections, and we're running on battery. So even if we were getting faster CPUs, we can't really use them because we're just going to drain the user's battery. And GWT, as it turns out, is in a quite unique position when it comes to performance, because the GWT compiler just doesn't know about just your JavaScript, it knows about all your resources and can optimize on all of them at once. If you want to get the basic things on web performance, there's a really good talk from Ilya Grigorik, one of our colleagues at Google. It's 3 hours long. It covers all the basics there. So I encourage you to check that out. There's a link on the slides. To me, there are different kinds of performances. There's startup performance, there's runtime, and of course, there's resource usage. So let's drill into all of these. Well, startup on mobile, well, startup on any browser drills down to have to download your resources. You have to parse them, and you have to execute them. What's happening?
Well, like the Academy Awards. Yeah.
Where was I? Well, startup performance on mobile drills down to you have to download your resources, you have to parse them, and you have to execute them. And the GWT compiler is really good at helping you with those kinds of things. So let's take a look into different things the GWT compiler is really good at. So if you're transferring text resources, such as HTML, CSS, or JavaScript, you should be transferring them as gzipped. This is basically like a free lunch. And with GWT, that's very easy. You're just going to zip up those compiler outputs up front, put them in your var directory, deploy a small servlet filter for that, and if the client supports gzip, you're going to use this, the gzip version. So you're not going to even pack the server CPU for that. Another thing that's pretty important in web performance is not to have blocking script tags. Because as soon as a parser hits a blocking script tag, the browser has to go fetch that script, parse it, and execute it. And after that, you can just continue browsing. So imagine doing that on a really slow network connection with lots of different script tags. But with GWT, you're just going to have one script tag. And from there on, the GWT compiler actually controls the bootstrap process, and he's really good at doing this. The other thing you need to get right for mobile, you don't want to re-download resources you've once downloaded before. So you need to set your HTTP headers right for caching. And with GWT, again, that's very straightforward. You don't need to think about individual resources and how to cache them. You basically get two kinds of resources. You do have a no-cache.js file, which you won't cache for long. And you do have a cache.js or cache.html file, which you can cache forever. On mobile, users are going to have a flaky connection, so sometimes they're going to be offline. So you need to be looking into actually using app cache for solving that, so this application still works even if a user doesn't have connectivity. People are actually writing articles on how hard it is to use app cache and to deploy that properly, but again with GWT, because the compiler knows all about your resources, he can just help you write that manifest file for you. You're just going to use a custom linker and get that manifest file ready. So this is one line in your GWT XML file. Then again, the GWT compiler is really good at minifying resources. We all know he's really good at JavaScript, but what's not so well known, he's really good at CSS and images as well. So if you have a big library, like mGWT, with lots of different widgets, but you're only using 20% of those widgets, the compiler removes all the other JavaScript, but the CSS as well. This also applies to images. Let's say you have a button with a small image on there. He also removes that image if you're not using the button. So that's pretty important as well. And the GWT compiler has been doing that since 2007, basically, inlining and spriting. This actually solves the amount of HTTP requests you have to do back to the server. If you're spriting images, you're just going to do one HTTP request. If you're inlining them, you don't do any HTTP requests whatsoever. Many of you are probably writing really big GWT applications. And for mobile, this is kind of a problem, because you don't want to ship a megabyte of JavaScript to a mobile device and wait for this slow network connection to actually download that. So within GWT, we do have a notion of actually shipping a small part of the application first, while the rest is downloading in the background. We call that code splitting. And with GWT, that's very easy and straightforward to use. You just are going to do a GWT.run async call, and the compiler actually takes care of splitting up that output for you. The other thing you want to be doing is you want to batch your data calls. So if your application boots up, there are going to be several presenters on the screen, and they're all going to need data. If they're all going to do an HTTP request back to the server, you're not going to have enough TCP connections back to the server. So what you actually want to be doing, you want to be using a command pattern and batching those requests into a list of commands, sending them off to the server, and getting a list of responses back and dispatching them back to your presenters. And again, with scheduler.schedule finally in GWT, this is very easy to achieve. So this is about downloading. Once you've downloaded everything, you still need to parse everything, and you need to execute it. And please keep in mind, parsing JavaScript actually blocks the UI. So you don't want to be parsing megabytes of JavaScript up front. And all the resources you're going to need, they have to be downloaded and parsed before you can actually do initial painting. This is quite important as well. So your HTML is going to be parsed into the DOM. Your CSS is going to be parsed into the CSS tree. And now the browser actually has to match those two trees into one, which is called the render tree. The next step, it has to lay out that render tree and then paint the render tree to the screen. And here are some common performance pitfalls. So if you get a huge, humongous DOM, that matching process becomes incredibly slow. So you need to be careful about how many DOM elements you're using. But luckily, with the GWT compiler, we can actually build mobile-optimized widgets, which just take care of that for you. The other thing you want to have good selector performance matching. So if the browser is matching those two trees into one, you want to be careful about how deeply your CSS selectors are actually nested. But as it turns out, CSS resources are really good at keeping those selectors unique, so you don't need to use deeply nested selectors if you're using CSS resources. So we've downloaded the application, it's running, but people still think that HTML5 applications have to feel somewhat sluggish on a phone. They have to be somewhat slower than native applications can be. But if you pay attention on how the browser works, and if you do your work thoroughly, you can be as fast or even faster as native applications can be. And there are two main points I actually want to point out. I call them native layout and native animations. So what do I mean by native layout? Well, you should be never doing your layout in JavaScript. You should be doing all your layout in native code. That's a very strange statement to make as a web developer because, frankly, we are never writing native code. Well, in a way, we are. Because if you do all your layout in CSS, the layout is actually executed by the layout engine. And this means it's actually executed by native code, so this is really fast. And on mobile phones, you got those really advanced browsers. So you can actually do that using the flexible box model. If you don't know about the flexible box model, there's a really good talk from last year's I.O. from Eric Biederman. You might want to check that out. And again, that's a really good case of what we can do with Grid for mobile optimized widgets. The other thing you want to do right is animations. Animations should be feeling on the phone really slick and fast. So some JavaScript libraries do animations like this. Let's say they want to move a div from here to there. And what they're doing is they're firing off a timer which fires every 16 milliseconds to get that 60 FPS rate. And then they're updating the position top and left. So what's happening here is they're basically telling the browser, move it 1 pixel, move it 1 pixel, move it 1 pixel. So what the browser does underneath, it updates the DOM, that updates the render tree. The render tree needs to be layouted and drawn to the screen. So what if you actually tell the browser what you want to be doing? I want to move that div from here to there in 300 milliseconds with a certain timing curve. Then the browser can actually find a decent way of executing that. And as it turns out, what happens then is if you do the whole animation in CSS, the browser actually draws a picture of the region you want to move, uploads that to the GPU, and moves that on the GPU. So you're not using any CPU whatsoever. And this is really, really fast and doesn't consume any real battery whatsoever. And again, this is something we can pack into the GWT compiler. So GWT has been designed from the ground up to be really, really performant. The GWT team always cared deeply about performance. They went into great length to actually optimize the compiler to be as performant as possible because in Google production, we care deeply about performance. And as it turns out, mobile exactly needs that performance. So using GWT for writing mobile applications is an actual no-brainer. But with GWT on mobile, we can actually do more. You can take today your well-written GWT application and run that on any modern phone or tablet using Phonegap. And if you stick to good practices with your CSS, you can actually achieve a native look and feel just fine. But as a web application, we can actually do more. We can use all the same cool APIs that the native developers are using, but we can use them through web standards. So this means that you can actually use the same code for your phone, your tablet, and your desktop application. In MVP terms, this means you can have the same presenter, you can have the same models, the same RPC, the same almost everything, despite having different views, because you want to have different views on a phone up to the desktop, you're going to have different navigation between those views. So if you want to do that today, you can do that using mGWT. mGWT got lots of mobile optimized widgets in there, on which we're going to start to improve in GWT proper with 3.0. And you can use Phonegap by using GWT Phonegap. And I actually want to show you some of that stuff running on different devices. So this is a GWT application running on an iPhone. So notice what happens if I hit reload. This is how long it actually takes to start up such an application. This is not a small application, so this is quite big. You can see the difference in layouting of such an application if I actually go ahead and turn the phone you can see, just a second, you can see where it was. Let's actually, sorry about that. Let's actually go first to full screen. So this is the same application just pushed to the home screen. So you can do different animations in here. Like we just said, those animations are actually done with CSS. This is why they behave slick and fast. So you can do all kinds of animations, what you like to do. Slide it in between. But you can actually put some time into and build different mobile widgets as well. So you can build something like a carousel where you have different scrolling widgets which just scroll fine, like this, and they can even be scrolled individually. You can even build lists with headers that push themselves out at the top, and which behave really fast. You can see that if I turn my finger here, how fast that is actually working. So, but since we are GWT, we can use the compiler to actually swap out the CSS for different devices. You can take the same application that I've just shown you and launch that on an Android phone, and it looks like an Android application. Because we can just introduce a compile permutation here and write different CSS. So none of the CSS that's there to power the style and looks of that application is inside that application, and vice versa. That really makes a huge difference in size. So on Android, you're going to have the same widgets that do the same stuff just fine. But this gets even cooler when you get to the third platform. And take an MGWT application with different styling that works fine on an iPad. So you're going to have the same widgets. You're going to lay out the application because it's a little bit different. You're going to have different MVPs running, of course. But it just behaves fine like you would expect it to be. We can even continue doing that. Just like that, and pull on an Android tablet just fine. So you can do things like pull to refresh widgets, really easy and really slick. But this is all just web UI. What if we actually wanted to go and access native functionality on a device? Well, we can do that using Phonegap. This is a GWT application running inside a Phonegap container. So as a web application, I can't read the accelerometer. So if I want to do that, I actually need that Phonegap container to run. But as soon as I hit start, I'm asking Phonegap to give me the values of the accelerometer. You can see as I turn my phone, the values are just changing with it. But I can even get one step further and actually use the camera. So this is still the GWT application running here. But as soon as I hit that button down here, we're actually changing to a native view which invokes the camera. I can take a picture and put that picture back into the JavaScript application. So let me do that. I'll pick up the phone. So let's probably do it like this. Everyone smile. Take that picture. So here's the picture. This is still inside a native view. And we can just hit use. That's a German phone, so this verwenden is use in German. And actually dispatch that picture back into JavaScript. And there, oh, it's not a nice one, but there it is. So this is how you can actually do device integration on a phone. But since this is a GWT application, we can actually tell it to run offline just fine. Remember I said we can just produce the manifest file for you. So just put the phone in flight mode. So it doesn't have any real connection whatsoever. So I can now take that GWT application just fine, hit reload, and it still works. Okay. So, oh, sorry. I actually want to talk quickly about gwtproject.org. So this has been mobile. There's one other thing which we wanted to address. Since GWT is now a community-owned project, we wanted to have a home for all the GWT-related stuff out there. So this used to be developers.google.com, which was a problem because only Google employees could do anything to it. So we thought about this. Since we are an open source project, we wanted to be the website and the documentation open source as well. So anyone can actually contribute to the website just fine, or the documentation. And so we figured Markdown these days is quite popular, and we thought maybe we can build a whole web page based on Markdown. And Because we don't want to put Markdown on a web server, we want to do kind of HTML, CSS, and JavaScript. So we figured we're just going to write a Maven plugin to actually convert that Markdown to a nice-looking homepage. So today, you can contribute to the website and the documentation using the same review process, the same guidelines that we use for GWT proper source code. So if you want to do something cool to the homepage, if you just want to fix a bug inside the documentation, you can just do that. If you want to do something cool, write an article, anything else, just talk to us and we'll figure it out. So if you want to do that, what do you do? Well, you go ahead and clone the Git repository. Then you take a look at the Markdown and fix the docs or write something yourself. And if you want to take a look at how it actually looks, you can just do a local MVN clean install. And you can take a look at target-generated site, and the whole site will be generated in that folder for you. And if you think what you've been doing is great and other people could benefit of this, you're just going to do a commit and push that commit off to us for review. And if you get a positive review, we will automatically push that to the new homepage, and it's going to be live on the page. If you want to know more about this, take a look at gwtproject.org/makingGWT And this is how it actually looks.
By the way, the website is now actually a GWT app.
Yeah, by the way, yeah, Ray is right. The GWT application is, the website is actually a GWT application. It actually uses GWT now. Okay. So, big question you might have is, when's all this going to happen? Steering committee got together, kind of trying to decide on the schedule. We're going to adopt a tick-tock model like Intel. Every 6 months, we're going to have a minor revision. Every year, a major revision. So, Q4 2013 this year, look for GWT 2.6, which would be a minor update. There could be there could be some other minor releases in between. Then for IO 2014, another 6 months later, look for GWT 3.0, which should have all the goodies that we've discussed here today. So before I go to questions, I want to shout out some thanks. First of all, I'd like to thank the steering committee for meeting for many hours over the past year to hash all this out. Thanks to Red Hat. Mike Brock is over there. He's a steering committee member. Thanks, Mike, for providing the BuildBot and the OpenShift resources on the Red Hat Cloud for hosting all this stuff. Thanks to Vaden and Julian Dramé, I hope that's how you pronounce it, of the GWT Query project. GWT Query is actually being used in the new gwtproject.org, and he worked with Daniel as well as Vaden to actually make the site look a lot better and freshen it up. I also would like to extend a special thanks to Thomas Breuer. If no one knows who he is or has been following the GWT Contributors News Group, he's been our largest GWT contributor over the last couple of years. He's fixed hundreds of bugs. He's probably actually fixed more bugs than the GWT team combined. And so I really wanted him to be at I/O this year, but he couldn't make it. So hopefully he's watching. And so I'd just like to extend a special thanks to Thomas for all his hard work over the years. Yeah.
So in summary, what's the future of GWT? I think it's pretty bright, but to summarize it up, faster development in an open setting for the modern and mobile web with fewer surprises, more compatibility with Java, and easier interoperability with the rest of the sort of non-GWT world. Thanks very much, and with that, I'll take the remaining questions. We have about 6.5 minutes. Thank you.
So you mentioned improve interactions between Java and JavaScript.
Yes.
Can you a little bit extend on that? I'm particularly interested in basically building a reusable library using GWT, but that can be used uniquely from JavaScript without having
yeah. So I am the original author of the GWT Exporter project, which basically you put annotations on methods like @export, and it exports a public API. The code's kind of bloated, and it doesn't actually generate a code that's easy for JavaScript programmers to eyeball and actually figure out how they should be calling it. We're starting to actually use GWT Exporter a lot within Google itself, and I'm putting a lot of time and resources to writing it essentially to make it much more idiomatic in terms of the output looking really like a handwritten JavaScript library and having less bloat and overhead. But there'll be more information on the GWT steering mailing list and in the roadmap. We're going to actually release the detailed roadmap very, very soon. It's a G Drive document. You'll be able to look at it. Next.
Hi, my name is Sebastian. In my company, we actually use GWT in enterprise solutions, and it's always been a bit of a scary moment, especially recently. Like, we don't have really support for GWT. As you mentioned yourself, Google was prioritizing the internal bugs instead of the public bugs. Is there any kind of
external support?
External support that can be
yes.
purchased?
If you talk to Mike Brock, right over there on the far right, I know Red Hat actually does some support, as well as Vaadin. If you visit vaadin.com, they provide official support for GWT externally. And so if you actually have a super high priority thing that you need fixed, they actually will do it. And behind you in line is Navigo. They might actually be able to help you out if you have some stuff, some issues too. But we are going to pay attention, community-wide, more attention to the issue tracker. And since we can accept bug fixes much easier, instead of people putting a patch into the issue tracker and it sits there for 2 years and no one looks at it, now actually it will go immediately into the code review system. Everyone gets emailed, someone looks at it, they actually just click a button that says it looks okay to me, and then you get an okay, you click a button and you commit it yourself, and poof, it's fixed and it's in.
If you paid attention to the issue tracker in the last month, we actually brought the amount of issues
We closed
down
about
quite
half the issues in the issue tracker.
Yeah, just to add on my question, do we have a clear picture on the commitment of Google in GWT? Like, we know currently some Google employees are committing to GWT, but do you have more commitment from Google?
Google is continuing to develop new apps. There are actually internal apps as we speak, like not old ones, but new ones actually are being created like every day using GWT. So there is, it's not being deprecated or we're not dropping support for it. If that's your question. Let me go to the next person before we run out of time. Yeah.
Hi. Yeah. So I've been following. Thanks. I've been following GWT for a while. I just wondered, how does the future of GWT fit in with the future of Dart?
That's a question that's been asked many, many times. I think it's orthogonal. In other words, Dart is not replacing GWT or vice versa. Google's a large company. We have many, many languages. Some teams choose Dart, some teams choose GWT, some choose Clojure compiler. Some people write stuff in jQuery actually internally at Google. YouTube's based on Python. Some teams build their apps in Go on the back end, some Java. There's no mandate from above, like Larry doesn't say everyone has to write everything in a certain language. Basically, people choose based on what they're interested in, and basically.
So do you think is GWT ever going to compile into Dart?
I don't know. Let me talk to me afterwards, and we can speculate.
Hi, I'm Dennis. Two questions, real quick ones. You mentioned the slides at the beginning. Are those available? Because I know this one isn't filmed. You didn't video this one.
It's actually filmed.
Oh,
yes.
It is?
Yeah, it will be available.
It will be available on YouTube. We also will make the slides available. The Google website, the new GWTproject.org, will have a public G Drive folder associated with it, and there'll be lots of documents we'll be dropping in there. Presentations plus like the steering committee meeting minutes plus the roadmap, the detailed roadmap.
Okay, second question. Is there someone like you guys or someone available to talk about GWT offline? Because I had some bugs in some of my GWT that I was hoping to just talk to you about here at Google I/O. But I noticed there's no sandboxes out there for GWT.
So we can talk afterwards.
You can talk to him afterwards, right after.
Okay, great. Thanks.
Okay. Go ahead.
Hi, can you say anything about the future of GWT Designer or potentially other tools for developing GWT applications?
Yeah, I actually don't know anything about that because that's actually run by a different team. That's run by Rajiv Dayal, who's in New York, and I think he deals with the team. John, do you know? Are they like partly in Russia? The team behind the GPE plugin. Okay. Yeah, they report. They have a different reporting structure within Google, so they actually don't report to the GWT team. It's kind of almost like a separate product. So I would actually have to ask them. But if maybe send a message to the contributors news group, and I can get Rajiv to respond to you, who runs the stuff.
Okay.
Yeah. Really quick following question. If there is plans to integrate Java and JavaScript more and is there any plan to put annotations on the produced JavaScript so that Clojure might be able to better process some things or optimize?
We actually already have something like that internally, and that's more what I mean about interoperability. The idea basically is that GWT can output JSDoc annotations and closurized code with like @constructor and @type annotations. So when you actually consume it from Clojure code, you'll get type checking, static type checking in Clojure. IntelliJ IDEA will actually allow you to like step through the code. The reverse is also true. Eventually you'll be able to point GWT to closurized code, and it will understand the Clojure annotations, and you won't have to actually write a JSON method to call Clojure code. It will synthesize on the fly an actual overlay type based on the type information that's present in the JSDoc. And that's what I meant about better interoperability sort of between the two languages. I got 38 seconds left. Anybody got one more question?
No time. This is actually counting up.
Oh, sorry. I'm actually over. I went negative. But if you have any other questions for me, you can see me outside the room. You can talk to me or Daniel. Thank you very much for coming, and see you guys maybe next year.